Hey guys, welcome back to the shop. Today we're going to forge the big knife of the Saami people. The Saami people are an indigenous group in the northern regions, from the northern regions of Norway, Finland, Sweden, and parts of Russia as well, I believe. And the name of this knife, if I'm saying it correctly, is Leuku, which means big knife. So I'm using 5160 steel here, and this right here is a classic example of really bad fish lips, which is not what you want to do. And the way to avoid that is to forge the corners in more, which is a little more challenging on a power hammer where the hammering is just straight up and down. But here's the way to fix that quickly and easily, because you do not want to leave this in your blade. That would create essentially a crack and just very bad. So we'll chisel off one side of these fish lips here, and that's actually going to leave a pretty well formed tip for this knife with fairly minimal finishing left to be done. And so we'll go to the anvil with the hammer. As you can see here, this would be the ideal way to avoid that in the first place, by forging into the corner by angling your hammer like I'm doing here. So we'll go ahead and refine this a bit more and get the shape we want. The spine on this knife is actually going to be straight, and at this point I don't have it straight, but forging in the bevel is going to curve that around a little bit more here, so just profiling it out at this point. So whenever you're forging a bevel in, you're spreading out the material on one side of the blade, and that's going to make the blade curve kind of like a banana, and that can be used to your advantage. And there's different ways of approaching this and dealing with the different expansion rates of the metal. And the primary way that I'm going to do this is start by forging in the bevel somewhat, and then thinning down the spine of the blade here on the power hammer. And that's going to stretch out both sides, not quite equally, but close enough to where we can go ahead and straighten things up with the hammer and not end up with any serious amount of deformation. So again, like I said, there's different ways to approach this and to deal with it. But the end result, of course, is to have a bevel forged in and a straight or appropriately curved blade. So continuing the bevel on down this bar of steel, which is starting out at a 1/4 inch thick, and we'll transfer back to the power hammer to address the spine thickness of the blade. And once we've got the length we want, I'm going to go ahead and start defining the tang. This knife is a stick tang design, which means that the tang is narrower than the rest of the blade and will fit into the handle. It is nice to have a power hammer or a press, or if you're on the anvil, some kind of guillotine type tool where you have equal top and bottom fullering devices, but it can be done just by hand with a hammer on the anvil as well. So we have enough material to forge the tang out. We'll go ahead and cut it off with the chisel here. Get this worked down on the 50-pound Little Giant, which is nice for these fairly menial forging tasks. Not a lot of finesse required per se. So just getting this forged down. And I was originally thinking about maybe doing a threaded end on the tang, so I forged that down a little bit more to facilitate that. But in the end, just ended up tapering the whole thing down. So the Leuku, I'm not sure how to say that still, the big knife of the Saami people, it's often sort of a wider towards the tip, narrower towards the grip, and that actually rhymes. So I realized that I hadn't quite accomplished that in the initial forging, and if I'd paid a little more attention to it, we could have gone ahead and tapered that a little bit before starting the bevel, but anyway, I got it taken care of. We went ahead and forged the blade down narrower towards the grip, so we've got the shape that we're after here. So doing some final forging on the anvil here, just touching the profile up here. Spent a little extra time on this one getting the profile forged in and everything pretty close, with of course still an appropriate amount of stock left to grind off near the edge specifically, but forged in the spine of the blade to the finished dimensions here. And we'll finish up some straightening on the power hammer here lightly and get this thing finished up. So you'll see this process in every video. This is normalizing, and then subsequent heat cycles are known as thermocycling, which refines the grain structure of the steel. But these are important, very important to the final quality of the steel of the blade. And you'll see me do this in. I don't think I've ever not showed it actually. So we're ready to go ahead and quench this blade and harden it. So I'm using AAA quench oil, which is the appropriate speed of quench oil for 5160 with that chromium content in there. It is a deep hardening steel, and you do not need a very fast quenchant. So there we are. It's tempered, heat treated, tempered, and ready to go. So we can begin grinding on this a little bit here. First thing I'm going to do is refine the spine a little bit and the edge or the profile of the blade. Of course, from this point on, it's very important to make sure that particularly the edge actually of the knife is not overheated, so we don't lose the hardness. But once we've got the profile refined just a touch, using the wire cup brush on the angle grinder to clean off all the scale and get a bright surface on the steel. And that way I can easily see the oxidizing colors from the heat here as we temper out the tang and the spine of this knife. So this is right at 3/16 inch thick on the spine, so already going to be a nice tough blade, but tempering out the top half of the blade, or top 2/3, it's going to be, that's about the top half I guess, but it's going to be super tough overall as a knife, which is what you want. You know, this is going to be designed for use in the woods chopping, you know, cutting poles, whatever. So we want it to perform above and beyond its expectation for the task. So pretty confident in that. So cleaning up the shoulders here for the transition from the tang to the blade, something we can match up our brass bolster to and get that fitted together. It's important that you forge in a taper to your tang, but I cleaned that up on the grinder a little bit more, as you can see. And now I'm going to file in the shoulders, make sure there's a decent radius there so that we don't have a stress riser, any kind of a sharp corner there, which would cause a potential weak spot. Even, you know, it's just sort of a extra measure because the steel is already tough and it's tempered out, so it's very tough, but you just want to make every possible concession to the end goal of this blade. So I started out to put a Scandi or a Scandinavian grind on this blade, as I've seen some of these knives made this way. And a Scandinavian grind is a single bevel where the bevel comes down to 0 degrees, and that is your edge. On your typical flat grind, hollow grind, etc., you have a large grind or bevel, and then it comes down to a thin cross section, at which point another bevel is created to make the actual edge. So we're going to try to do a Scandi grind on here, and I went ahead and sanded up the hand sanded the bevel so it was smooth and shiny, and I'm just running it across the buffer here a little bit, cleaning that up. I intended to come back and hand sand it a little bit more. Here I'm actually stropping the edge, and you can see, of course, that the edge is facing the direction. I've got to say this properly, but it's the wheel has to rotate away from the edge, otherwise this would be an instant catastrophe. So if you do strop your edge on the buffing wheel, be very careful, because if it's going the other direction, it will immediately catch that edge, and very bad things can happen. But anyway, we have a razor sharp edge to work with now. And here I've got a piece of, it's a pecan branch, a nice dry West Texas pecan branch. So pretty hard wood, and I'm chopping right in this spot with all these knots. My goal here is to see what this blade will stand up to. Now let me talk about the Scandi grind for a minute. The Scandi grind is really good for certain things and not the greatest for others. So one of the inherent drawbacks to the Scandi grind is the weakness right at the edge, and you can see this demonstrated here. I've got some edge rolling. We do not have edge chipping, however, which is this right there. What you're seeing is where I actually dropped it on the concrete, and same with at the end right there. Kind of came out of my little testing handle, which is another probably not OSHA approved practice. But anyway, we got some edge roll, and we do not want that. We don't want that, even though this pecan wood is quite hard. So I went ahead and ground the edge down. I abandoned the idea of a Scandi grind, put a bit of a saber grind on there, brought the edge back to, it's probably 7/1000, so still pretty thin, maybe 10, maybe closer to 10. I'm going to go ahead and put a bevel on it. So the problem with the Scandi grind is that there's not very much material right at the edge. It gets, you gain material quite quickly because it's a fairly obtuse angle. But right at the edge, it's relatively weak compared to your typical flat grind or even your hollow grind knife. Now, it works extremely well for carving wood, and typically something like a softer wood, like your spruce or birch, which you're going to find in the northern regions of most places. This is not that wood. This pecan is not the equivalent. So really, here we go again. I'm sort of working my way up to what the appropriate edge profile is here, and there we are again. So if you build a knife and you dial in your heat treat that's appropriate for the application, and you end up with edge rolling, that kind of thing, the next thing you need to look at is the profile of your edge, the actual physical properties of the steel. Because what you're looking for is a combination between hardness and toughness, but the actual amount of steel that you're working with at the edge there is a factor. So I went ahead and, I think it was my third try, went through multiple pieces of that pecan wood and got to where there was 0 edge deformation, and it did not shave. Did it shave? No, it did not. So I went ahead and did the old pine 2x4 test, chopped twice through it, and it performed that test with flying colors. And unfortunately, I forgot to turn the camera on, but yes, went through twice, shaved very easily, quite nicely. So I'm very happy with the way this blade turned out. So I wanted to talk a little bit more about the edge profile, even though we're moving past that now in the video, because you can take, say, a chef's knife that's appropriately heat treated for that task, and with that super thin edge, if you go try to chop even a pine 2x4 with it, you'll end up with either chipping or edge deformation because it's simply not designed for that. And so which ironically, I've been building a lot of those similar knives with pretty thin edges, and so I came to this project and was sort of reminded of these principles here. So, you know, building the knife for what it's designed for. So, you know, if I had chips out of that edge, that would tell me on this knife, that would tell me that my heat treat was too hard and I needed to, you know, soften it up, temper it out just a bit more. And that's not what we had. All of our steel was still there. So that tells us that our edge geometry and profile needs addressed, and so got to where everything was dialed in. And I will say too that once I started getting that saber grind on there, you know, you notice that the edge bites in better to the wood because you have that clearance. And so, quite frankly, the Scandi grind, it's not necessarily designed as a chopping knife, and unless you're using it on a thin blade, you're not going to have that cutting clearance that allows you to get work done. So that more obtuse angle on the Scandi grind is going to want to bounce out of the wood more than bite in. So altogether, the end result on this blade is good. So we've got a better cutting clearance, nice strong edge. So what you're doing there is you're thinning out that big bevel, that big profile, which allows you to make the primary bevel a little more obtuse and give you that strength. And so just finding that balance. So got a good result here, and I'm happy with it. So moving on to building the handle, I got a brass bolster type setup there, and that's fitting on nicely. And I've got some elk antler. We'll go ahead and create a spacer here. I want this to fit snugly, so just a little bit there to tap that on there. It's snug. Of course, you got to be careful not to drive that on and crack it, but that's working out nicely. So for the main part of the handle, I have a nice piece of stabilized burl wood here, and we'll go ahead and get that drilled out for the tang. So I've got everything fit up here, going together nicely. It's time to assemble this whole thing with epoxy and make this a nice solid construction. Using a brass spacer or washer here to tap this down here, since the brass butt cap fits tightly on the tang, and I don't want to mar that up anymore, so get that tapped down on there. Alright, so this is the next day, and the epoxy is all set up and cured, and I'm going to go ahead and trim off the end of the tang here so we can peen that down to make a nice permanent mechanical lock on this handle, so it's not going to come off even if for any reason the epoxy failed, which I have never had happen before, but it'll be a nice solid handle. So I've got a lot of material to remove to get the shape of this handle. And there's a couple different directions you could go with this. You make sort of a nice tapered handle like I've got right here, but I chose to go ahead and create sort of the bell or the flare at the end of the handle. This is going to help with grip retention when using it in chopping, and help it keep it from slipping out of your hand. And there's no guard on here, but the use of this knife doesn't require one. You know, even with up close cutting, you know, the way you're using it simply a guard is not necessary. So there we go. There's the finished product. Got it cleaned up, buffed up. I like that burl wood, the way it turned out. And the elk antler and the G10 spacers there. Overall, pretty happy with the way this turned out, and it'll make a great blade for somebody out in the woods. So appreciate you guys watching, and we will see you on the next video.